Hello everyone. Our project is a peer-to-peer chat application using image steganography. I will start by discussing the implemented steganographic approach. The approach relies on pixel swapping inside the image ports. The first step is to divide the image into 3x3 subblocks, where the data bits are going to be embedded and extracted according to some criteria. So in this example, this 6x6 image will be divided into 4 3x3 subblocks. The extraction criteria is as follows. First, the average of the intensities of the block is computed. Then the intensity of the middle pixel is compared to this average. If it's less, then the secret bit is 0, and if it's more, then the secret bit is 1. So in this first example, the middle pixel intensity, which is 5, is less than the average intensity. Therefore, the secret bit is 0. In the second one, 49 is less than the average intensity of the block, therefore the secret bit is 1. The bits are embedded in the blocks by rearranging the block's pixels according to the criteria mentioned before. Moreover, if pixels have to be swapped during embedding, the pixel nearest to the block's middle one is chosen for swapping. In the first example, we want to embed a 0 bit inside this block. However, since 5 is already less than the average of the block intensities, therefore nothing will change. In the second example, we also want to embed a 0 bit in this block. However, the middle pixel is greater than the average. Therefore, we have to swap it with another pixel that is less than the average. And at the same time, this pixel has to have the nearest intensity to 49. Therefore, we are going to select pixel value 39.
From the previous step, we embedded the bits of the message randomly with the pseudo-random generator to add a layer of confidentiality to the message, but it's not enough. We have to satisfy other security principles to make the app more secure and robust. So we'll add extra layers of security to provide integrity and authenticity to the message. This is done by encrypting the message itself before embedding it. The encryption process is done in 2 stages. The first is formatting the message, then encrypting the message. After that, we embed the encrypted message in the image randomly as discussed before. In the formatting stage, we append the chat message itself with the name and the IP of the sender, as well as the name and the IP of the receiver. Also, we add an extra bit to switch between the private and public message feature, whether the message is broadcasted to everyone or privately sent to a specific user. The next step is to encrypt the formatted message from the previous step. We first generate a signature using the DSE algorithm with the private key of the sender. This sign is then concatenated with the formatted message, and the resulted string is encrypted with the AES algorithm with a symmetric key shared between the users. Now, to secure the login process itself, we use the same techniques used before to encrypt the login process. So we concatenate the IP, name, and the public key of the sender in one message. Note that this public key sent here is the one used by the receiver to decrypt the signature. After that, we first generate the signature of the string as before, and then concatenate the string with the signature and encrypt them with the AES algorithm. Finally, the resulted string is embedded randomly in the image as discussed before. We use in the login process the UDP protocol to broadcast the login information to the other users. But in exchanging the encrypted message, we use the TCP protocol because it is more reliable with larger data. Finally, with these extra layers of security, we have achieved confidentiality by randomly embedding the message in the image. Also by encrypting the sent message with the AES algorithm using a symmetric key. This way, only the users of the application are the ones able to decrypt the message. We have also achieved authenticity and non-repudiation by using the DSA algorithm with the private key of the sender. So now only the public key of the sender can decrypt this signature. Also from the signature, we compare it with the digest of the message to ensure that the message is not modified, and this way we achieve integrity. The same principles also apply in the login process, in which we use the signature and the symmetric encryption.
Now I'm going to show you a demo of the application. At first it starts by asking for the user's desired name. Here is the list of the available users, and the first entry is the lobby chat. In order for any user to send a message, at first he needs to select an image to hide the message inside. As you can see here, it tells you the height capacity of the selected image, and in our case it's around 12 kilobytes. Now let's send a public message to the lobby. Let's try a private message to user 2. This number denotes the number of unseen messages from user 1. Now let's reply with another private message. However, at first we need to select an image. Finally, when user 2 exits, he disappears from the list of available users. The first kind of attacks is traffic sniffing, and it is a kind of passive attacks. So let's start the sniffer. As you can see here, a secured identity is sniffed through the UDP protocol. However, since the messages are strongly secured, therefore this attack will fail. Another attack is the man-in-the-middle attack. This attack occurs when someone between two communicating users is actively monitoring, capturing, and controlling the communication transparently. For example, the attacker can reroute an image to another user. These attacks will fail as both the senders and receivers addresses embedded in the image are compared to the packet's source and destination addresses respectively. If they are equal, then the received image is authentic. As you can see in this example, an image is received from this IP address. However, no user is authenticated on this IP address, and also the sender's address embedded in the image is different than this one. Therefore, this image is not authentic and its message is discarded, and as you can see, it did not appear in the chat history.